So new chapter, wave. Let's see. I would say the simple definition is how a disturbance, and by disturbance I really mean energy in this case, and here's the part that's new, moves through a system. Nothing has moved through any system, a medium is what I meant to say. Nothing has moved through anything yet. All right, so far in this class, nothing has moved through anything. We started with point masses, then we let the masses have a size so they could rotate, then we let them deform a little bit, and we kind of pushed on one end of a fluid column and the other end moved. That's sort of a disturbance moving through. But now we're going to think of something beyond just those simple masses. We're going to think of a medium that has different properties at different points in space. Okay, that's kind of the idea. But let's look at a few examples. Let's look at the disturbance. Right, the disturbance over here and the medium over here, and then you can guess the wave. That'll be the fun part. All right, so the disturbance is pressure, and the medium is the air. What is the wave? 1, 2, 3. Sound, yes. So sound, everything you've been listening to is me vibrating the air with my larynx, maybe? Yeah. Vocal cords, yeah, vibrating the air. It vibrates in your ear. Ow. Okay, that's been happening all semester. Sounds a little intimate, actually. We could have the disturbance be the height of water. All right, what kind of a wave is that? It's a wave. Dude. All right. That's how you pronounce that, wave. Okay? We could have the disturbance be the deflection of a string. That's the one we're going to do. That's called, what's the word when it's the quintessential one that everybody does? I forgot the word. Okay, we're not going to name that one. We'll do it in a minute, though. And then we could have a disturbance of the electric field. Ooh, getting into next semester. In space. Does anybody know what a disturbance of the electric field in space is? Electromagnetic wave, which is light. Right? Light is just a wave of the electric field through space. I think I want the word canonical here. Your first wave is the wave on a spring. Now, a new wave was discovered and won the Nobel Prize like 2 years ago. The gravitational acceleration in space. Right? That's gravity waves. Because of the kind of interaction gravity is, we know it should have waves. They're just really hard to detect because they're so weak. So it took until just a few years ago for them to actually detect them by having some little system so sensitive that when a black hole blew up somewhere, it made enough of a jump that the system could detect it with 2 interferometers in Europe somewhere. I don't know. Okay, it was a big deal, though. Okay, we basically saw gravitational light was this last one. So that's what all these things are. All it is how does a disturbance go through a medium, and what is the physics of it? How do we describe it with physics? And it's sort of like the oscillator that we get excited when all these different ones are described with basically the same equations. That's what we're looking for. That's why we start with a spring, with the string.